We are taking notes on classification of matter or types of matter. You should have already watched a video on this and made a concept map. So please do that first. Otherwise, we are in the note packet right here under classification of matter. So I don't usually do fill in the blank notes. I have things highlighted on here because of how I did the notes last year, but you should be able to follow along and fill in the blanks as we go. So, what is matter? We need to know that definition because chemistry is the study of matter. It is anything that takes up space and has mass. You can say has mass and takes up space, it means the same thing. So, we are going to pretend you're scientists and you've discovered a piece of matter. So, you have to figure out what kind of matter that you have. And matter is defined into two categories. The first category is a pure substance. The second category is a mixture. So our first question will be, does it have an exact ratio? Pure substances have an exact composition or an exact ratio of what they're made of. Mixtures do not. Mixtures have variable compositions. So in this picture here, this is liquid bromine. The brown spaces here is empty space. There's only bromine in this beaker. In this beaker, there's only water. Again, it's empty space in between these molecules. This beaker has bromine and water, but it's a weak solution of bromine and water. This is a stronger concentration of bromine and water. So pure matter can only be called what it is. This is only bromine, this is only water. This is a mixture. We can call this beaker bromine with water, and we can call this beaker bromine with water, because it doesn't matter how much of each one there is. Variable composition is how we distinguish between pure and mixtures. So let's look at pure substances. The first and most pure substance in the world is an element. It cannot be broken down any further. So write down these notes, but if you look at a carbon atom, carbon has to have 6 protons. If you change this number, if you take away a proton, then we have to call it bromine. If you add a proton, we have to call it nitrogen. So you cannot change what carbon is made of, or else you have to change the name. Same thing with the compound. Compounds are made of 2 or more elements that are chemically combined in a set ratio. This is not a huge deal, but there is a difference between the word molecule and compound. Molecules mean it's an atom bonded to itself. Compounds have 2 different types of atoms, and we'll come back to that later. So let's go back to what a compound is. Compounds, again, have a formula. So formulas look like this. We'll use them a lot this year, and this formula represents that exact ratio. So when you combine 2 hydrogens and 1 oxygen, you get water. When you combine 2 hydrogens and 2 oxygens, you get carbon dioxide. So when you chemically combine something, you're making something completely different, and you can't change this ratio. So again, water is water only if it's exactly this. Hydrogen peroxide has to be exactly this. So it has that exact ratio or exact recipe. Also, super interesting, once you chemically combine something, these things are different. For example, hydrogen exists as a gas at room temperature. Oxygen exists as a gas at room temperature. When you combine them, we can have water as a liquid at room temperature. Sodium is a metal that reacts violently with water. If you put a piece of sodium even in your hand, the moisture in your hand would make the sodium ignite. Chlorine, if you breathe it by itself, is a poisonous gas. But if you put sodium and chloride together, you all of a sudden have salt, table salt, which we cannot live without. So 2 things that would kill you when they're chemically combined become a life-sustaining chemical. So compounds have very different properties than the elements that make them. That's the whole point there. Okay, so again, water is a compound. It has this exact formula, and those formulas represent the ratio. So this 2 here means there are 2 hydrogens. I don't have anything here, but because I put an O there, we know that there's at least 1 oxygen. Sodium and chlorine, there are no little numbers down next to it, but writing the symbol for sodium and chlorine automatically tells me I have 1 of each. Calcium carbonate is another one. It's made of calcium, carbon, and oxygen, again in this exact ratio of 1 calcium, 1 carbon, 3 oxygens. Don't worry about those formulas. I just want you to recognize that something written like this is called a formula. If it has a formula, it is a compound, and compounds are pure substances. So mixtures are different than compounds. they can have a different ratio. They don't have a set amount of atoms or elements. So if you have a mixture, one of the ways you'll know you have a mixture is it's super easy to separate them. You can separate it with filters, like when you make coffee, you filter through that coffee. You can separate it with magnets, and you can separate it with boiling point. We did this when we exploded the pennies. That metal inside the penny heats more quickly than the copper on the outside. So not boiling point, that would be point of, or melting point that we used. So we melted that metal in the middle, and we were able to separate that mixture where you had copper sitting next to this other compound. So that penny is actually a mixture of two types of metals just laying next to each other. That's all a mixture is. You have things laying next to each other. Remember, mixtures can have different ratios. So this is a mixture of sand and water. If I added more sand here, it's still called sand and water. So I don't chemically combine them. Here's a picture of separating something with a filter. When I pour it through the filter, there's no chemical reaction here. Water comes out the bottom, and I have collected my sand. All right, so let's talk about different types of mixtures. The first type will be a homogeneous. The prefix homo means the same, geneous is unknown. Again, remember, it's an unset ratio, but in homogeneous mixtures, everything's spread out evenly. You can't see the little pieces. So I can't see the little pieces of sugar and alcohol mixed in with this water to make wine. And I can't see the little pieces of bean juice mixed in with the water to make coffee. You can't see all the parts of blood to make blood. They are evenly mixed together, made of super small parts. They look like they're made of the same thing. These are called solutions. So anything that we use the word solution for is a homogeneous mixture. We'll talk about alloys in class, but basically if you take a liquid metal and you stir it up with another liquid metal and you let it cool, you can make an alloy called brass. So brass is actually made from melting zinc and melting copper. Stir them up, let them cool, and now all of a sudden you have a single colored solid solution called an alloy. Liquid solutions are more what we'll talk about. The way you know it's a solution is light will go right through it, and I will show you that in class. Heterogeneous, the prefix hetero means different, geneous is unknown. Things are unevenly mixed because we can see those chunks. And there are some examples. There are two types of heterogeneous mixtures, and this is where it gets a little tricky. Colloids are usually liquids that are thick. They have particles in there that are still small, but they're big enough that they would scatter light. So if I shined a ray of light at this glass of milk, the light would go in all different directions. Okay, if you shine a ray of light at a solution, you'll see the beam go right through. So these are all examples of colloids. Again, usually it's going to be thick liquids. Blood would be we had blood as a solution on the other page, so it's a tough one. I actually would call it a colloid. Paint, soap, toothpaste, milk, fog is actually a colloid. You've got little tiny particles of dust and water vapor in the air. And so those are those examples. So I apologize for that blood example, that was bad. Heterogeneous mixtures, really quickly, they have really big pieces, and just like when you wear suspenders, your pants might fall down. In a suspension, the particles are so big that they will fall to the bottom. So best example is just water from a muddy lake. But really, if you can shake anything up and things will stay suspended for a while but eventually settle, you know that it's a suspension. So salad dressing, we have to shake up, like Italian salad dressing. Your ketchup and mustard, you have to shake that up before you use it because it's settled out in the water. So here's a review of the differences, and we will do some demonstrations and some labs on this in class.